Hello. Welcome back to the videos, right? Today we're looking at section 1.3, which is all about the graph of functions. So remember, a lot of this is review, but maybe some of it will be kind of new too. This section seems like it's like a lot of pages, right? It's like multiple pages, but there isn't a whole lot on each page. It's kind of like we're jumping all over the place here. Hopefully it doesn't take us too long to get all this done. We'll see. But we actually have 5 objectives for today, which makes it seem kind of long. But our first objective is that we're going to find the domain and ranges of functions and use the vertical line test, which we talked about last time. The vertical line test to determine if something is a function, right? Is it a function? Is it not a function? Then we're going to determine the intervals on which a function is increasing or decreasing. So what we mean by that is, okay, from here to here it's increasing, and then from here to here it's decreasing, and then it goes back to increasing maybe, or whatever, okay? So when is the graph increasing? When is the graph decreasing? We're going to determine how to find the relative maximum and minimum values of a function. So if you're looking at it, a function that's already drawn, how do you find it? And then more importantly, using our graphing calculator, how do we find it? And then we're going to identify the graph or identify and graph, step functions and other piecewise defined functions. Sorry, that's one word. I don't know why there's a space. Piecewise is one word. So we're going to look at how do we, right? Last time we evaluated piecewise functions, right? Plugging in a value into that piecewise function. Today, we are actually going to practice graphing the piecewise function. And then the last piece is we're going to determine, is a function even or is a function odd? Okay, so that's our last objective. So we're just going to jump right into it and start with this first objective. And really, we're going to look at domain and range, right? What is the domain and range of a function? So right now, this is a function, right? It does pass the vertical line test. If I move a ruler or a pencil or whatever from left to right, it does not cross this graph more than once at any one spot. So it is a function. So that's good. They also tell us it's a function. So part A says use the graph of the function f to find, and then part A wants us to find the domain. So remember, domain are any x values that work. So like out here at 3, there's no point of the graph that works out here at 3, right? Because this is an endpoint. If there was arrows, that would be a different story. Since this graph is stopping, the furthest to the left I can go is right here at -1. So -1 is the smallest x value I can have. And then as I go to the right, the biggest x value I can have is 4. Now we just have to figure out brackets or parentheses, right? So at -1, since it's a closed circle, I can have -1. So it's a bracket. And then at 4, since it's an open circle, I cannot actually have 4. I can have all the way up to 3.9999999 forever, but I can never get to 4, so it's a parenthesis. Pretty good, hopefully. Part B says the function value, so I want to find what is f of -1. So what do I get out when I plug in -1? So right here, if I plug in -1, what do I get out? Right, so my x is -1, my y is -5. So f of -1 is -5. And here, what do I get when I plug in 2? Well, if I plug in 2, I go up till I touch the graph and I get 4. And then the last part is, what is the range of f? So range is up and down, right? So what is the lowest y value that I can have? And in here, the lowest y value I can have is -5. And what is the highest y value I can have is right here at 4. At -5, it's a closed circle, right? I actually have a point there, so it's a bracket. And at 4, I actually do have a point there, right? 2 comma 4. So this is also a bracket. Boom. That's it. Okay, so there is an extra example here down at the bottom of your page. Go ahead and try it. And then when you feel confident to check your answer, go ahead and hit play on the video and check your work. Okay, so hopefully this is looking good. Here's our answers here. So at -5, 1, 2, 3, 4, 5, my output looks like it's 3. And again, I'm just going to go ahead and assume that it's a whole number. It's not going to be a decimal or anything like that. And then at 4, 1, 2, 3, 4, come down, and that looks like -3. Okay, and then what is the domain? So the furthest left I go is right here at -10. Right? And since it's an open circle, it's a parenthesis. And then since I have this arrow here, my domain just keeps going on and on and on and on and on forever to infinity. So there's my infinity and always parenthesis and infinity. Same thing here on the range, right? What is the range? Well, the lowest my graph goes, I'm going to try not to mess. That was not a very good straight line. Really, more or less, right? Looks like -5. Now the question is, but Miss G, there's an open circle here, so wouldn't it be parenthesis? And the answer would be yes if this point also wasn't here. So I still have a value at -5. It's just not this one. Okay, it's over here. So it's still a bracket. So hopefully that's a nice little review. Yeah. We are going to look at now how to find the domain and range from an equation. So we just have to remember that domain is what numbers can I plug in, right? And range is what numbers can I get out. So in this equation, for example, I have a square root. I know that I'm restricted on a square root. I cannot take the negative, wow, breathe. I cannot take the square root of a negative number. Okay, I can't do it. Well, we know from Algebra 2 we can, but in terms of domain and range, we can't get imaginary numbers. So in this case, when I'm finding domain, I cannot take the square root of a negative number. Can I take the square root of 0? Yes. Okay, so 0 is the smallest number I can have in under a square root. So when I'm looking at this, I say, okay, what number would give me 0 here? And hopefully you guys got an answer of 4, right? 4 minus 4 is 0. And the square root of 0 is 0, so that's fine. And then what other numbers can I have if x is 5? Can I have that? Yes. Okay, if x is 6, does that work? Yes. Okay, and so on and so forth. So any number bigger than 4 or equal to 4 works. So my domain here is x is greater than or equal to 4. Remember that you also could write it 4 to infinity. Either way. Okay. So those are all the numbers I can put into this equation. Any number 4 or bigger. For my range, we have to think about what numbers are we allowed to get out of the equation. So when we're thinking the smallest number I can put in to my equation is, or the smallest number I can take the square root of is 0. And what do I get when we get 0? right? The square root of 0 is 0. So f of x can never be a negative, right? I'm not going to take the square root of a number and get negative, ever. I'm not going to, it's not going to happen, okay? So I'm going to say f of x can't be negative. So because I'm never going to get a negative number, the smallest number I could ever get out of my function is 0. So the smallest number I can get out is 0. What's the biggest number I can get out? Can I take the square root of 1,000,000? Can I take the square root of 1,000,000,000? Yeah, right? It just keeps going. So the biggest number I can get out is infinity, but the smallest number I can get out is 0. And again, I could write it like that, or I could write y is greater than or equal to 0. And make sure you use y because it's range. Okay, so I want you to try this one for the extra example. So really pause the video, think about what numbers am I allowed to put in, right? And then what numbers am I allowed to get out? So really focus on it, see if you can come up with the right answer, and then when you're ready, you can check your work by hitting play. Okay, so let's check our work here. My domain is actually all real numbers, right? So we can write x is in the set of all real numbers. The reason is I can plug any number I want into x squared. I can plug in negatives, I can plug in positives, I can plug in 0, I can plug in decimals or fractions, right? Anything I want can go into there. So my domain is x is in the set of all real numbers. Or you can write it negative infinity to infinity. Now, when we're talking about range, I have to think about, okay, what's the smallest number I can get here? And so let's think about that. If I plug in a negative number, it becomes positive, right? Negative 3 squared is 9. Negative 2 squared is 4, and so on and so forth. So the smallest number I can get out of here is if I plug in 0. 0 squared is 0. So this number, the smallest it'll ever be, is 0. Well, if this is 0, then 3 minus 0 is 3. And that's how I got this number. Right? That's the smallest it'll ever be. So I'll just show you. 3 minus 0 is 3. Okay? And then after that, 3 minus, if I plug in 1, I get 1, which is 2. And then if I plug in 2, I get negative 1, and so on and so forth. So 3 is actually the biggest it'll ever be. And then everything else is going down from that, right? And getting smaller. So that's how I got negative infinity to 3. And I can actually get an output of 3, so there's a bracket there. You also could have checked this and graphed this on your graphing calculator, and that would have been okay too. Okay? Or you could have just thought about what does this graph look like? If we go back to algebra 2, right, x squared is a parabola. This plus 3 tells me it's moved up 3. So there's my vertex. And then the negative tells me it opens down. So it's doing something like this. So here, looking at the range, I can clearly see that it goes down to negative infinity and goes up to 3. This is 3. So lots of different ways you could have thought about it. Last thing we're going to look at on this page is the vertical line test. So again, we've already talked about this, right? If I take my ruler and I go from left to right or right to left, doesn't matter, it can only touch the graph in one spot, okay? If it only touches the graph in one spot, then it's a function. So if I just draw here like random vertical lines anywhere I want, there's one, right? You don't even have to draw them if you don't want. I'm just doing it to show you, right? These are only crossing the graphs in one spot. So this right here is a function. okay? Versus over here at B, if I draw a line here, do we see how it crosses in two spots? It crosses right here and right here, right? So this is not a function. That does not pass the vertical line test. Even though like here, if I draw a vertical line here, it only crosses once, but it's more along, it has to be any vertical line that you can draw. So even if you can draw one vertical line that crosses more than once, it's not a function. So hopefully we're feeling good on being able to recognize function, not a function, and domain and range. We're actually going to move on now to identifying what interval functions are increasing, decreasing, or constant. So we're going to look at this little box real quick. Okay, so the key here is just you always go left to right. So on your graph, you always go left to right, right? Or left to right. I don't know which way you're seeing me. I feel like the camera's flipping me. But you always go left to right. So if it's increasing, it's going up from left to right, okay? If you are decreasing, it's going down from left to right. And if you're constant, then it's staying the same. It's not increasing or decreasing from left to right. So that's just the only thing that I wanted to point out here is that it's always from left to right, and you always use the x values. Okay, so you always use your x values. So that is the interval. The interval is always going to be what x values is it increasing, right, from left to right? What y value or what x values is it decreasing from left to right? Things like that. So actually, let's look at an example and then I think we'll kind of have it down. So the only thing missing here, these should have arrows. Sorry. So we're going to do 3 examples together. And we'll move on. Okay, so from left to right, I need to know when is my graph increasing. So I'm going to start here at my arrow. Even though I know this goes on forever, right? Let's just start here. As I go from left to right, my graph is increasing and increasing. And even here, even though it looks like it's constant, it's still increasing. And it's increasing and it's increasing and it's increasing, and then it goes on forever. So actually, this whole graph is increasing the whole time. So this one's kind of quick because this graph is increasing the whole time. So we say it's increasing from negative infinity to infinity. And so we're going to write our intervals in interval notation. So hopefully that makes sense. Okay. So, and we're using the x coordinates. Again, we wrote it up above, but it's here too. From left to right. So from negative infinity all the way out here, it's increasing, the graph's increasing, the graph's increasing, 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 and so on and so forth. So let's look at one a little bit more interesting, one that's not just increasing the whole time. I'm going to scroll up as much as I can. There we go. Perfect. Okay, so here I'm just, again, adding arrows. So sorry. My pen doesn't like me writing today, maybe? That's weird. Now it's working again. Okay. So those all should have arrows. Okay, so as I draw, or as I go from left to right, so I'm just going to start at the arrow, my graph is increasing, 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 and then now it's decreasing, 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 and then increasing again. So I don't have any constant points, even the points of turn, right? This maximum and minimum here, this vertex, essentially, is not increasing or decreasing, but it's not constant either. It's just a point, okay? So we can write down, let's write on what intervals the graph is increasing. Okay, so down here, right, it keeps going down, down, down. So my graph will be increasing from negative infinity, right? And it's increasing, 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 increasing all the way to here, to -1. So it's going from negative infinity to -1. It's increasing. And, okay, then it's decreasing. And then right here at 1, it starts increasing again, right? So 1, increasing, 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 increasing. So it's also increasing from 1 to infinity. And notice I'm using parentheses. We're only going to use parentheses when we're talking about the intervals, because at the actual points themselves, the points of the minimum and maximum, it's not increasing or decreasing. So we can't include that in a point. Okay, then we can say, okay, this graph now is decreasing. And I'm starting here, right? This little section right here is the decrease point. So I start at -1 and it's decreasing all the way to 1. So it's decreasing from -1 to 1. And that's it. That's what I'm looking at for my increasing, my decreasing, constant. So again, only using parentheses and using the x values, the x coordinates, to write out my intervals. Okay, we're going to look at C, and then we get to move on. Okay, so for C, increasing, I just go from left to right and then write down the interval as I go. So I'll show you exactly what I do. Okay, I start on the left and I say, okay, this is maybe like -2.5 or something. Who cares? It doesn't matter, right? I'm increasing, increasing, increasing all the way to 0. So I'm increasing from negative infinity. Why are you not letting me write? Negative infinity to 0. And increasing. Okay. Then at 0, I'm constant, right? It's not going up or down. So I'm constant, 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 constant until 2. So I need to add one more in here if my pen will let me write. Okay, there we go. I'm constant from 0. Oh no, my pen. To 2. There we go. Okay. And then at 2, I'm decreasing, decreasing, decreasing all the way to infinity. So then from 2 to infinity, I'm decreasing. And so then that's what that would look like, right? Constant or increasing, constant, decreasing. So I literally just go left to right, and as a direction changes, I just write down that interval as I go. You are going to want a graphing calculator for the next bit. So if you need to pause the video to go get a graphing calculator, or if you need to go to Desmos, Desmos is going to be a free graphing calculator that you can have, or that you can use. So it's just desmos.com, DESMOS.com. There's also some really great apps for your phone that have a graphing calculator on them. So if you're curious about those, go ahead and give me a shout, and I can definitely help you out there. But I'm going to go ahead, pause the video, get your graphing calculator ready, and we'll move on. Okay, so we're going to talk about the relative maxima or relative minima values. As my calculator loads, there it is. Okay, so the only thing here is like a true maximum or a true minimum would be no points go higher or lower, right? But when we're talking about a relative, it just means it's a turning point. Like, see how this graph continues on? There really is no true maximum here, but my relative maximum is this point because it is a turning point. And if you take out the arrows of my graph going on forever, it is a maximum. And same thing with the relative minimum. And you can have multiple relative maximums or minimums, okay? But like in this case, I mean, I don't know if we even have to label it, but like here the relative maximum is 1, 4, and here the relative minimum is -2, 2. So it's just a coordinate point that's a high and a low, okay? So really we're gonna learn how to do this on our graphing calculator. So we're gonna do one together and then you guys are gonna do one. So it says use a graphing utility to approximate the relative minimum of the function. So I'm gonna pull up my graphing calculator here. So hopefully we can all see that. And I'm gonna go into my y equals. I need to clear this out. And I'm going to graph this function. So the function is 3x squared minus 4x minus 2. And then I've been messing around with my window in helping other students. And so my window's a little messed up. So if you're like not sure if your window is good to go or anything, you can always hit zoom and then number 6 standard, and it'll change it back to the standard graph. So there is my graph, okay? I know it's a parabola because the equation is x squared. Okay, so I actually have a minimum here, and it's right in this general area, and we're gonna review the steps on how to find the minimum on our graphing calculator. So what we're gonna do is we're gonna go second. So here, I'm gonna clear out the bottom here. Anything that I press as a button will show up down here. So if I start going too fast, you can look at my key press history. So I'm gonna go second and then the trace button because I wanna get to calculate, which is up here. Okay, now I have two options. I can calculate the minimum or I can calculate the maximum. So if you have a minimum and a maximum, you have to do this twice. But in this problem, I only have a minimum. So I'm just gonna go and hit 3, or you can scroll down to 3 as well. And this will ask me, first of all, it'll show the equation up here, and that's the equation I want, so that's good. And then it'll ask me left bound. And what that's asking you is, hey, will you put a boundary on this so that I don't go any further left than it? My calculator doesn't want to go like up here or whatever, right? Just give me a point anywhere that's to the left of what you want me to find. So it can be there, it can be here, right? Anywhere that's to the left of your minimum. And then hit enter. And this little line shows up. Of course, I did it so close to the X or the y-axis, you can't even tell, sorry. But this little dashed line shows up, and this tells me that my minimum is to the right of that line. See this little arrow that kind of points to the right? So, okay, my minimum's to the right of that line. Then it says right bound. Well, now I need to pick a point that's to the right of the minimum. So somewhere in there would be fine. You could go up further if you wanted to. You could go down further if you wanted to. Just make sure that it's very clearly to the right. And I'm going to hit enter. And then this other line shows up. And this other arrow shows up. And this says, okay, you've just told me as a calculator, right, that the minimum you want me to find is between these two lines. And it is, so that's good. Then the next one is a guess. You don't have to guess. Guess is like you just get very close to it. You're like, somewhere there. It doesn't matter. You don't have to guess. You can just hit enter through it. So hit enter, and here it tells me the minimum. So I'm going to go back here and I'm going to write that down. So the x coordinate is 0 point, right? Lots of sixes, and it just keeps going on forever. And then the y coordinate was negative 3.3. What? 3, there we go. And it just keeps going on forever. So at this point in our math career, we should be able to turn these into fractions, like right away, okay? So the relative minimum of this graph, 0.66666, so on forever, we should know is 2/3. Okay, and then negative 0.33333, okay, I have how many, well, I know that this is going to be 1/3 because of the 0.33, so I have negative 3 and 1/3. You guys remember how to convert this to a improper fraction? It's okay if you don't. You multiply, you ignore the negative, so we multiply 3 times 3, which is 9, plus 1 is 10. Keep the denominator the same, and then put the negative back in. So that is the coordinate. I don't know why my pen doesn't want to write for me. That is the coordinate of the minimum. Okay. So what I want you guys to do now is I want you to try example 6 on your own. And there is a minimum and a maximum for this one. So make sure if you don't see it, that you fix your window so that you see the minimum and the maximum, and you're going to find both. So you're going to do that same process. You're just going to do it twice. And you can go ahead and leave your answers in decimals because the crazy decimals you get don't convert to fractions, okay? And then when you are done and ready to check yourself, go ahead and hit play.